Okay, so this is what we saw when we were just looking online about some continued fractions today.
Yeah.
We just calculated the square root of 10 one. We were able to redo that calculation.
Yeah.
Square root of 10 is 3 plus 1 over 6 plus 1 over 6 plus 1 over 6 plus 1 over 6. But we saw this amazing different continued fraction for pi. 3 plus 1 squared over 6 plus 3 squared over 6 plus 5 squared over 6 plus 7 squared over 6,
Yeah.
etc. Now this is a different kind of continued fraction than what we study. We've always studied 1 over, 1 over, 1 over, 1 over. This doesn't have the 1 over, so you can't calculate this continued fraction through our split, flip, and rat method. You need different methods. But one thing that's very surprising about these two continued fractions is what?
Well, they both have the 6 plus something. They have all this.
They have all those
And
sixes.
you also have a 3 plus.
Yeah,
And then the 1 is technically the same. The 1 squared is 1.
right?
So all of this is the same.
Yeah.
And then the 6. Cool.
It's pretty incredible.
Yeah.
So the continued fraction for the square root of 10 and this particular generalized continued fraction for pi are very similar.
Yeah.
Another thing that's surprising about this is that you read a lot, or you hear a lot about pi that it doesn't have any patterns in it.
Yeah.
But this is a very simple pattern. So, although it is true that when you write down the digits of pi, they don't appear to have any patterns.
Yeah.
The digits appear to just be random.
Except when you organize
When
them
you-
in a continued fraction.
When you organize, well, in the continued fraction that we normally looked at, we also didn't see. It was like 3 plus 1 over 7 plus 1 over 1 plus 1 over 15 or something.
Yeah.
Maybe it was 3 plus 1 over 7 plus 1 over 15 plus 1 over 1 plus 1 over 292, something like
Yeah.
that. We didn't see any pattern there, but when you change it, you get, not only do you get a pattern,
You get
you get a pretty easy pattern, and
Yeah.
it looks incredibly like the square root of 10.
Yeah. I wonder what they have in common.
I wonder what they have in common. Yeah, it's pretty amazing. Pretty amazing. And this is why people, especially in number theory,
So you continue fractions.
study continued fractions, and this is some of the, I don't think this continued fraction came from Ramanujan, although maybe it did, I don't know where it came from actually. But this is when Ramanujan sent his letter to Hardy. Hardy was very impressed at the continued fraction work, and he said he'd never seen anything like it before. So, very neat way of representing numbers. So, there you go. Good morning, learning a little bit more about continued fractions.